And a good Tuesday. Hopefully everybody can hear me here. Let me know. I'll get everything logged up here on the other computer. We'll talk about the computer models that we were talking about yesterday, well, how that impacts the weather forecast. And before we get into that, we'll have a bit of an update here on the severe weather potential that we've got coming up for tonight, as some things have changed on that, and some of maybe the kids will be interested in with that, maybe the parents, or maybe you're just tuning in for the first time on one of these. We'll get you caught up to date on the severe weather aspect of tonight's forecast, and then we'll go in to more of that virtual weather talk and school lesson coming up for today. So let me go ahead and get things logged up here on the other computer. Sounds good. Looks like the audio is working. So that's always a good thing, always a good sign to start off the day. So we mentioned yesterday we'd have the 3 chances of storms in the overnight hours. We got the one last night and early this morning, the next one on the way for tonight, and the third one, that'll be Wednesday night going into early on Thursday. So this is Getting Schooled here. We're in week number 3. We've talked about severe weather. We've talked about all kinds of earth science topics, and this week learning about weather technologies, which will feed directly in to how to put a forecast together. So basically we're going through that step-by-step process on actually how to do that from a scientific point of view. But again, I want to start off talking about the severe weather threats. If you're just tuning in right now and trying to get an update on that, be aware this is right now we're doing this at 11 o'clock here in the morning. So if you're going back and not watching it live but watching this on a video later on, just keep in mind at 12:30, right around that time, we'll get another update from the Storm Prediction Center on an update with this official severe weather risk. Right now we're under that slight category that is for tonight. I think generally 10 p.m. to about 2 o'clock in the morning is, if you had to put 4 hours on it, that would be that window here where we're looking at the greatest potential here for some of those storms during that time. So something to keep in mind as we head towards later on for tonight. But let me kind of highlight what we're looking at right now. One, lightning and downpours, number one threat, number one concern tonight. Large hail, the ingredients for large hail coming into place more so than probably any other severe weather threat when you actually look at the stuff that is classified as severe weather. These storms could certainly have enough instability to get going. There's a lot of moisture with it, and the freezing level is fairly low into the cloud, and so that allows those ice crystals and waters to kind of collide and start to form those ice crystals, and it could become a little bit bigger. And right now, if we were looking at the greatest severe weather threat, kind of the shading here, what we're looking at is kind of when those storms develop tonight, probably in our Michigan counties and maybe just to the north here when the storms still kind of get organized tonight, somewhere between about 8 o'clock through about midnight or so. That might be the most intense part of it, but something we're keeping a close eye on. There is a chance of a tornado with these storms tonight, and also wind damage is possible, but both of those threats lower compared to the hail, and obviously a lot of lightning and rainfall expected with that too. So just want to bring you to date on that at noon today. Actually, during the 12:30 half hour, we'll have an update on that severe weather risk if anything is shifted or changed with it. But also the timing with predictors. We'll get to that coming up. Now, today we're going to talk all about here when it comes to getting schooled. We're talking about computer models. Yesterday we talked about radar and satellite, how those two pieces of weather technology are so important for us. Big camera up in the sky, floating around in outer space, taking pictures of the Earth. How cool is that we get to use that tool to help forecast? Radar is really important. We've been using it all day long today, and we'll be using it again for tonight. And we showed you some of the behind-the-scenes stuff that we do yesterday to indicate if we're looking at hail or if we're looking at rotation inside of a storm. Today, we're talking about what we do when we're forecasting the weather, let's say tomorrow or even tonight for that matter. But if it's anything too far into the future, we need some help from computers. And so I'm going to run through what we're looking at. So I'm going to go over to the other computer. How many of you guys, let me know here on the chat, how many of you guys like math? How many, I know a lot of you guys like math, a lot of you guys can't stand it at all. We're thankful as meteorologists that the computers handle the worst of this math, and you'll see what I'm talking about. These equations can become really, really long and intense when it comes to solving these math problems. So computer model, that is just that's like a calculator. In fact, everybody's got one of these, or mom or dad's got one of these phones, I would take it. So you open up the calculator app right there, right? If you hit 2 plus 2, hit the equal sign. Hopefully it says 4. It looks like this calculator is right. It's doing a good job. Well, now we can do a bunch of math equations to figure out what the weather is going to do. It's as simple as that, or as complicated as that. But if we know, let's say Fort Wayne, Indiana, which is, well, what is that, roughly 50 miles? Well, no, more than that. Probably 80 miles, 100 miles away. Regardless, if we know a point, let's say Fort Wayne is 100 degrees. They're not, but let's just say they're 100 degrees. The winds are coming out of the southwest, which means that hot air would be moving our way. We can calculate how long it's going to take before that hot air gets here and how hot the temperature is going to be. So it's solving a lot of these math equations, and we got to plug in lots and lots of these equations. But the problem is that we need some help because these equations become really, really long. Down here at the bottom here of the screen, this is one of these equations in a very simple form. It starts with a triangle, which we call delta. Then we got z, and then it equals minus rd tv, and go over gravity, and then it gets lenticular equations. It turns into a big mess. Now we start plugging in all the information on all these equations. They become really long. In fact, I could probably write these equations out on the wall. They wouldn't want me to do this here, but I could probably write it on the wall all the way around the studio. And then I would have to write some more equations and some more, and I would have to get some help. I'd have to bring in Jay Birch back in here. I'd have to get in Heather Polloff. We would have to get in Dan, and we'd have to solve all these equations by hand. And even if we were to do that for tomorrow's forecast, it's going to take me probably, if I got a lot of help, it's probably going to take me 3 or 4 days to get tomorrow's forecast done. If I'm doing it by myself, forget about it. It's probably going to take me 7, 8, 9, 10 days to do it, and that's without very much sleep. So that means if I am trying to put your forecast together by just solving these math problems out by hand or even using my iPhone calculator here, it's probably going to take me a week or more by myself and probably a few days with some help of my friends to get all that done. And then it doesn't matter because by the time you get the answer, by the time you get the forecast from calculating all this out, you already know what the weather was a few days ago. It's old news. It doesn't matter anymore. So this is where we get some help with the computer models. They're basically like big, powerful calculators solving all these math equations for us. And they really help us out quite a bit when we're trying to put a forecast together. So let me show you what we're looking at. And I told you yesterday I would give you some websites, and I'm going to get to that here coming up on how this works. But this is kind of a look at what's going on. These math equations look at the Earth, and they break everything down in these little grids. Every little spot on the globe gets a little box. And that's going to be where we get our answers and kind of figure things out and kind of sample the weather in little itty-bitty boxes so we can try to calculate what's happening. Is there a storm there? Is it hot? Is it cold? What's going on? And then we try to figure out how those little boxes and little pixels around the globe can move when it comes to cold air, hot air, and all of that. So let me go right to what the answers are. And this is it. This is our answer page of what one of the computer models will show. And it doesn't say, I don't get 2 + 2 = 4, right? That's not my answer necessarily. But instead, I've got lots and lots of answers on this display. Each black line that's here that you see, that's an answer to a problem. Each color that you see, these are different answers to a problem. And then each little box where you see a symbol here, it tells us the wind direction, how fast the wind is. There is actually not just one answer on this problem. This math problem isn't just one answer here on this map. I have hundreds, probably thousands of answers on this one particular map at one time in the future. And so when we're looking at these computer models, we're looking at hundreds and hundreds and probably thousands and thousands and thousands of answers all at the same time, which helps us put a forecast together. There's a lot of different things that we're looking at to try to see how the weather is going to change with time. Here's another look. This is above our heads. There's all kinds of colorful stuff. I love colors. I absolutely love looking at the different colors, but this is important information, letting us know that, hey, in a certain spot right in the Great Plains, there's a big jet stream trying to come in, and that's going to produce some moisture and some winds aloft. And then this funny looking colors over here is basically an indication of the type of storminess that we're looking at. So you get these bright colors. That's a strong upper level storm that can produce thunderstorms and snow and that type of thing if you get the other ingredients there. So I mentioned a couple of weeks ago that we're looking at all these ingredients coming together at the right time to figure out what kind of weather we're going to get. This is how we do it. We look at lots and lots of weather maps, of which are basically just answers of mathematical problems. That's all we're doing here. So I'm going to give you this website. I'm going to give you a little bit of time to write this down. If you don't want to look at the website, you don't want to write it down, you don't have to. But if you've got pen or paper, and you want to look at these computer models yourself, and I'm going to run through them here coming up, but this is the website to do it. So it's weather, so WEATHER dot COD, so COD, kind of like the fish, COD, dot edu, and then there's a backslash here, and then forecast, FORECAST. So it's weather.cod.edu/forecast. This is going to be the one website that I'm going to give you, and we're going to spend a little time on going through. So again, I'm going to give you a little bit of time. Make sure that if you want to write that down, that you've got it there. And here's going to be a lot of information on this page that I think is going to be fascinating to some of you. There's going to be a lot of things that you don't understand, and that's okay. That's fine. But I do want to kind of show you how this works for everybody. And the one thing is that you're going to see a time on all these different answers, our weather maps, which are our answers to our problems that we're trying to do. So here is, once you get that written down, and you can see the what we got here on the side, you see the time. It's this 0Z, looks like it's a foreign type of time. It's a type of international time. So the only thing that we have to remember is that this time of the year, whatever this time is, we just minus 5 hours from it. So if it says 5Z, well, that really means midnight. I'll explain more coming up. It'll probably make more sense. But again, hopefully everybody's got this down. If not, we can come to it later. Weather.cod.edu/forecast. All right. So let me take you over to this website, and this is what it's going to look like when you pull it up. Now, we're talking about severe storms today, and this whole page that I'm bringing up here are the different computer models. On the left-hand side, you're going to see different times. I'll go to the 6Z because I know that was a longer model. I'll use that one as an example. And then I can go down and I can select where in the country I want to look, and I'm going to pick the Midwest. Okay. And now, all of a sudden, I've got a computer model. This is what we look at. These are behind the scenes. This is the secrets that weather forecasters are looking at, right, to put a forecast together. The circle that I just drew in, this is Toledo, okay? This is Ohio right here. Here's Michigan. Oh, can't forget about the UP, beautiful UP, there we go. There's Lake Michigan, here's Indiana. All right, so I'm going to get rid of all that, but I'll circle in, there's Toledo. And this morning, we had that rain come through. All right, I'll take off the brown dot that was Toledo. And this computer model came out. This is what I was looking at this morning. And we had a little thin band of rain come in, and then we had some more steady rain. But it was a lot heavier south of Toledo, and it showed that really well. You can see how that's a little heavier to the south of Toledo. So that was this morning. So at the top here, it says 12Z. We got a minus 5 from that. So that gives us 7 o'clock. So this computer models for what the radar was supposed to look like at 7 o'clock this morning. And that's pretty darn close to what actually happened. This is a really good severe weather model, this HRRRR here. We call it the pirate model, we'll call it R. All right, so let's go back and look at it here. Take back off that. And then we can go forward in time towards the top. So there's 6. Take it forward, you can see the rain moving out. That's exactly what happened. The rain was gone. And then everything's fine. This is tonight. This 00Z, we got a minus time from that. Actually, it's minus 4. I'm sorry, I messed up. It is minus 4 this time of the year. And it's minus 5 in the summertime. So this is actually 8 p.m. tonight. Anyway, so 8 p.m. tonight, 0Z. You can see these storms firing off back to the west. That's what that computer model shows. And we take it forward I'm going to take it to 2 more hours. And you can see these storms starting to fire up. And I talked all this morning about how I think that 10, and I just did as well when we started this Facebook Live, that 10 p.m. to 2 o'clock in the morning would be our best chance of severe thunderstorms. And you can see these storms developing right here. Well, this is Toledo. It's not quite to Toledo here at 10 o'clock, but it's already in our counties of the Northwest. And then if we take this a little bit farther forward, we'll get it to about midnight tonight, which would be about 22 hours on here, and it goes right over Toledo, and it pushes through, and then it moves on out by 2 o'clock in the morning. So you can see, now this isn't, we have a lot of weather maps, a lot of computer models we look at, and pretty much all of them agreed, had kind of the same answers, that about 10 p.m. to 2 o'clock in the morning was that window for the storms to come in. So sometimes we'll look at one computer model, and it won't be the same as another, and so we have to kind of use our brain to figure out which one is right. But in this case, you can see that they all kind of agree, and they show that band of storms coming through. And then if we keep taking this out, each hour that we take it out, it keeps forecasting farther and farther. So you see no rain, no rain, no rain. And then there's more rain that tries to develop back out here as we head towards later tomorrow. Now that's just one computer model. If I go, so we looked at this, the pirate model, right? We'll call it the R model. And then I've got other computer models up here, all kinds of ones. I'm going to go to this one. This one's totally different, the GFS. And this one goes out really far. Goes all the way out for about 16 days, more than 2 weeks. So I'm going to go back down to Midwest. And you're seeing different colors here. This is a temperature map. Down here, there's all kinds of different levels. The 250, 500, 700, 850, 925. These are all levels above our head that we look at a lot. And then you have surface and you have precipitation. These are things closer to the surface. So these are like our high temperatures. And here, let me, you can also see how these temperatures absolutely soar. So there's where we get into the low 70s today, and there's 70s, even possibly hitting 80 back towards Illinois. But these temperatures, as we go out, get really chilly here. This is coming up for Easter, and here, as we get into Monday, this is cold stuff. So I'm going to draw in where Toledo is, and here's Toledo, and that's showing below freezing by Monday morning. And then I can go over, I'm going to show you one more thing here. I can go down to precipitation, and we'll throw up precipitation type. And so here's our rain kind of dancing around. Now notice tonight, this is the same thing as that other computer model had. And it isn't nearly as bright and everything else, but it still has the rain through here at this time. It's because those boxes that all these measurements happen in are much larger. You can kind of almost see them. I mean, they're almost like little diamond shapes all over the place here. Well, those are our boxes that are getting measured. So this computer model is great because it goes out almost 2 weeks and it covers the entire globe, and we can see how everything's moving. But it doesn't do as good of a job with severe weather. But it does do a good job on figuring out rain and snow chances and temperatures even going really far out, like a couple weeks out. And what is that? That's snow? My goodness. So if you go out far enough, it's trying to mix in a little there, a few snow flurries. And then this is next week, and I mentioned this on air today. I didn't talk a whole lot about it because we've got a lot of time for this to change. And if you were to look at this website, you're going to see this change too. But this is going into the early morning hours on Monday. And here's Toledo, and you've got the rain basically all to the east of I-75, and then you got snow coming in. Now, will that happen? Maybe. This has got it. Some of our other computer models are kind of hinting at it. And then there's more snow heading into Monday, going into Tuesday, potentially. So, hey, we haven't talked a whole lot about this on air yet. I just mentioned a few wet snowflakes. It may not happen. There's a lot of time for this to change. But this is what we're looking at behind the scenes to try to understand and figure out what may happen. And just to give you an idea, these computer models do change quite a bit. So I can go to a different computer model at the same time and take it out, and probably be a little different. So it's a little different. It doesn't look, but it still has some of that snow. So a lot of fun. The farther out you go, though, the more inaccurate these models are going to become. So it's great that we can look out. Look at this. This is April 20th, and my goodness, the storm's trying to put in a bunch of rain and a bunch of snow all the way on April 21st. But here's the thing. That snow and that rain, I looked at another computer model this morning, doesn't even come close to showing the same thing. These things will flip around all the time. When you start getting out, this is really far out. 339 hours from now, that's really, really far out. So anyways, that's kind of a behind-the-scenes look at what we're dealing with all the time that we're taking a look at when it comes to the forecast. So that's kind of behind-the-scenes look. And hey, that website is free. You can look at it anytime you want. There's a lot on there that you probably want to understand. But if it is something that you're interested in, you can kind of run through it and kind of get an idea of how weather works, some of the data that we're looking at behind the scenes. So I want to leave it up to you guys for the rest of the time for any questions that you have when it comes to how we forecast the weather, what we're looking at. It doesn't have to be about computer modeling, but I wanted to run through this today because yesterday we talked about some of the important weather tools that we use. So we talked about satellite, we talked about radar. Today we talked about computer modeling, which we spend a lot of time looking and analyzing computer model data. And then tomorrow I'm going to talk about observations, and I'm going to have you guys start to observe the weather. Even if you don't have a rain gauge, even if you don't have a thermometer, that's okay. I want you guys to start a chart. This will be starting tomorrow. We'll talk more about it tomorrow. But I want you guys to start writing down the weather conditions each day. Even if it feels cool and cloudy, that's fine. That'll work. But we'll talk about the importance of that and how important it is, the forecasting. And then next week, you guys get to make your own forecast based off of some of the stuff that we've gone over. And we're going to go over some forecasting exercises together. So it should be a lot of fun, even though this is in a virtual environment and you're at your house and I'm here. I'm excited about doing this, and I have done this with some actual classes before, and it's always a lot of fun. So I'm going to pull up the questions here and try to get going on what we've got. All right. Sean Bell asking, what about the tornado parameters for tonight? So tonight we have, last week in particular, we talked about the different ingredients that have to come together. And if you could remember, and if maybe you joined me last week, maybe you didn't, but we talked about there has to be that lift to get those storms going and get them organized. And then there has got to be that wind shear. And I showed a graphic with kind of the spinning tubes, and they're already kind of there in place, kind of invisible spinning tubes. And then you got to get that lift to kind of push that up into a vertical standpoint. We need both of those. So here's the setup for tonight. We have decent wind shear loft. There's no doubt about that. In fact, we've got great parameters for hail. We have some pretty good wind shear loft. The question is, will we have enough instability, which will lead to that strong lift that could potentially get us a tornado? And there's more of a question mark on that. And the reason why is it depends on a lot of what happens late afternoon and this evening. If we get a lot of sunshine and the temperature soars into the mid-70s and the storms fire up into that environment a little quicker, we may have a bigger tornadic threat, and the tornado parameters in that case will be a little higher. And some of the computer models we've looked at have showed those tornado parameters a little higher. Others have shown more clouds, a little cooler weather, storms come in later, and it doesn't really look to be that big of a deal. So it seems to all kind of hinge on that tonight. I don't think that we're talking about a major outbreak or anything like that, but I also think that there's a chance for maybe a stray tornado or two in the strongest cells. And that's why we're going to keep an eye on it. And if you are at home and you can't get us on air, we're going to be having updates here on Facebook. My page, 13ABC's page, Jay will be in too. We're going to have you covered all the way through social media land. 13ABC First Warning Weather app is a great tool because even if you just kind of don't want to be bothered by everything else but want the alerts when that storm gets closer to you, you can set up those alerts however you want to, which is a great deal on that. Joe Moore also asking, what is the likeliness of tornadoes? Right now, that likelihood, it's a possibility, is definitely a possibility. I wouldn't say it's likely that that's going to happen, but it is a possibility. So it is something that we're concerned about. It just really comes down to how much instability do we get and how quickly do those storms get in here. So right now, I think southern Michigan is probably a little better zone for some of those storms that could become tornadic, but there's a lot of ifs that have to be figured out that we don't know yet. So possibility, not necessarily likely, is the best way to predict that, or to sum that up here. Okay. Michael Jason asking, any snow? So as we showed there on the computer models, no snow over the next couple of days, way too warm. But as it cools down, in fact, next week is going to be a cold setup altogether. I would not be surprised at all if we at least get some flurries at some point. Is it enough to lead to snow accumulation? Too early to tell, because while I was showing the one computer model that was showing a little bit of blue on the screen, you also have to account that the ground is really warm and some of that would melt. The other thing is that if I were to show you some other computer models at the same time, they wouldn't agree. And that's where a lot of times if we go on and talk several days away and say there's a couple different possibilities of where the storm could go, if you start looking around at those computer models, you'll see that those possibilities of where things could go, when the farther out you get, become more and more confusing, even for us as forecasters to try to figure out where things will go, because sometimes there's a lot of different possibilities. But is it possible? Yeah, I think it is possible, and we're going to go into a cold pattern, and we're not home free quite yet. Is there going to be a tornado in Fremont? Kelly Warner wants to know. Odds are no. Odds are, if you're just going to look at the odds for anywhere tonight, the odds are not great that we're going to have a tornado in your town. But there is a possibility that a storm somewhere could produce a tornado, and so that's why we're going to be watching it really, really carefully as we go through this evening into tonight. Will Toledo be affected by the storms? I think that there's a good chance that, so the most likely thing that's going to happen for tonight is that we'll have rain and we'll have lightning and thunder. And that there's an 80% chance of that happening. So that means that anywhere in the viewing area, anywhere where you're watching us here in Northwest Ohio or Southeast Michigan, you have an 80% chance of getting showers, lightning, and thunder, and you have a 20% chance of missing out completely on that. So there's a pretty good chance that you'll get that. Do you get the severe weather? That becomes less likely, but it is possible. And large hail is the biggest concern for the severe weather. We could get wind, but wind isn't the big concern like it typically is. Jacob's got a good question here. How far in the future can the models go out and give accurate forecasts? Accurate forecasts, that's the key. It varies, Jacob. So we'll start off with, we have the computer model that I showed you, the GFS. That one goes out 16 days. I don't think I have ever seen it to where I would classify it accurate 16 days out. I don't think I've ever seen it accurate beyond 10 days out. Now, these model trends many times 10 or 14 or 16 days out can kind of give us general guidelines of what may happen with an overall weather pattern. Maybe it's showing a colder environment or a warmer environment. But as for is it going to rain or snow at a certain time, it's really tough to tell. I would say generally anywhere from about so usually somewhere between about 5 and 8 days is usually where we have a reasonable confidence that the forecast will be accurate. And it varies depending on the weather situation. There are times where I come in and I put a forecast together and feel very confident on what's going to happen with the weather through 4 or 5 days out. And then the last 2 days, it's like, we have some computer models saying 70, some showing 50. That's a tough situation. We have to show one number on the 7-day forecast, and if you have computer models that are showing 20, 30 degrees apart. There are many times where we've had computer models show a foot of snow and thunderstorms for the same storm on the same day a week away. That's maybe where you put the rain-snow mix and say we're watching it. Because sometimes that's kind of the situation you're into. If there are two good possibilities, really can get that confusing 6, 7 days in the future. And then there are times where you can look out 9, 10 days and have a reasonable feel for how things are going to come together. So very good question there from Jacob. See Jennifer asking, let's see, are the satellites at your house a weather one? So Jennifer, we have satellites up in space that all of the weather community gets to use. So like 13 ABC doesn't have like our own satellites that we launch up into space, but instead based off the about $1 out of taxes for every person in the country actually goes to fund all the satellites, all the weather radars, all the National Weather Service's tornado warnings and warnings in general that come out. All of that is being funded in that way. So that means that that $1 out of taxes that basically each person is contributing in a given year is going to fund all of that. And because of that, that is all of our data. The computer models that I just showed you, you have as much of a right to look at that as I do or somebody from the National Weather Service does, because all of us as Americans are funding that weather data, and that's how that works. Also on that website, if you look around, you'll see satellite, you'll see radar, you'll see a lot of other data on there. So it's not 13 ABC's satellite in particular, but it's everybody's. When it comes to radars, there are some TV stations that build their own. We've had one for many years, as we talked about yesterday, that has done a great job and a great service here in the area. But when it comes to the National Weather Service radars and the satellites that we're able to use, that's basically everybody's in the countries, including yours. Let's see, Angie asking, can we ask a question about last week's video? Absolutely. Do they measure the strength of a fire-nado like they do a tornado? They do not. Usually it would be, they measure, and the reason why is that they measure tornadoes based off of their damage, essentially, not how big they are or how ugly they look or anything like that. They measure them off of their damage. And after everything's done and the storm goes through, you can see a tornado damage really clearly based off of everything else. In a fire-nado, everything is getting burned up. There really, a lot of times afterwards, there's not much of an evidence that a fire-nado went through because it's not the winds or the circulation that's doing the majority of the damage, it's the fire itself. And so because of that, there really isn't a need to do that when it comes to rating fire-nados. But great question. Solomon wants to know if the satellite has Wi-Fi. That's a really good question. It's not like Wi-Fi like we think about, but satellites have their own signal beam that they're sending directly back down to Earth. So satellites were around before Wi-Fi was ever a thing, but that's a great question. Why is a computer model, Courtney wants to know, why is a computer model important? So a computer model, if we were to figure out, computer models are solving lots and lots of math equations really quickly for us, very, very fast. The computers are able to solve, like I said, if I got all my friends here and we got the whole team together and we are dedicated to solving tomorrow's forecast by hand for the math equations, we would still, with everybody here, it'd still probably take us 2 or 3 days at a minimum to get all those equations done and to come up with that forecast for tomorrow. Well, if I'm coming up with a forecast for tomorrow and it takes me 3 days to get it, who cares? You can go out and tell me what the weather's doing and have a much better idea than what I would. You know, we would just continue to work on our work and get it all done, and at the end of the day, it doesn't matter. So computer models can solve lots and lots and lots of math equations really, really fast, and then we can see them, and then we can sort through all that data, and it helps us figure out what the weather is going to do, not only, say, for tonight, because a lot of times tonight we can look at the radar and figure out, okay, there's some storms building, it's warm, it's humid, pretty good environment for some storms to fire up. We could figure that out without a computer model telling us is going to happen. But if we were to go, say, tomorrow night with that chance of rain, that'd be a little tougher. And then if we're talking about there's a chance of rain on Easter, there'd be no possible way I could tell you, no way that I could tell you that it was going to, that we're going to see that rain on Easter with reasonable confidence anyways, unless they just say it's going to rain every day. I would be right in that case, I guess. But if I'm trying to come up with an accurate forecast and I want to know what it's going to do on Easter, I need a computer model to help me out. There's no other way we can do it. So that's a good question too. Nicole asking, so we may have snow tonight. No, we're not going to have snow tonight. That won't happen tonight. We'll have thunderstorms tonight, and it's still going to be really warm. That snow that was showing up there on the computer model, that was for next, it was trying to put it in here as early as like Monday morning, but it was more Monday night, like going into Tuesday of next week. And so that's a possibility to where it could mix with a little bit of rain. But that's one of those things where the computer model shows it, but do we include it in the forecast? There could be reasons why we would do that, why we didn't do that. This morning I went on TV and said it's going to be cold. We've got a good chance for some rain. There might be some wet snowflakes mix in Monday night. And the reason I worded it that way is because the one computer model has rain switching over to snow and it's really cold It's got highs, it has temperatures into the mid to upper 30s. Our other computer model that goes out that far is showing temperatures in the low 50s with just pure rain. So both of those are possibilities, but we have to kind of figure out how things are going to change as we get a little bit closer. Let's see here. Drayden wants to know if you can see a hurricane forming. We can see a hurricane forming. This is where satellite is the most important tool for hurricanes. If we didn't have satellite, we wouldn't have a good idea. In fact, the Galveston hurricane, you've heard stories about Hurricane Sandy. You've heard stories about Katrina. You've heard stories about Harvey. That was more recently, a devastating flooding hurricane. But if you go all the way back to the Galveston, Texas hurricane, that was, I believe, 1902, and now it's going to bother me because I might be off by a year or two, somewhere between 1900 and 1902. That hurricane was heading right towards the United States. We had no idea. We had no satellites to help us out. So the only thing that we didn't have radar, we didn't have satellite, we didn't have those tools like we have today. And so at that time, Cuba actually had a very good weather bureau, a decent weather forecasting service there. And they had alerted the United States that this thing had gone through Cuba. They alerted us and said, this is bad. Be careful. Based off of our observations, we think this thing is going to be heading towards Texas. But it was unusual because it was really sunny before it hit. And as a hurricane came in, it changed so quickly that people didn't have time to get out of the way of this thing. And a lot of people flooded. It was an absolute disaster. It was a major problem. Not only there, but this storm was so strong that it continued to go up towards Chicago. So basically from Texas to Chicago, it cut the country in half. And at that time, we didn't have internet, we didn't have Wi-Fi, we didn't have telephones. We had telegraph services, what was connecting the country. And it literally separated the United States west to east because it cut every single one of those telegraph lines all the way up to almost Chicago. It was a devastating blow. We had no idea it was there. We had no idea it was coming because we didn't have satellite. So satellite is a huge help for us to see that it's coming. 1900. Thank you. 1900. So it was not 1902, but 1900 for the Galveston hurricane. Let's see. And what's the forecast for Wood County on storms? Same thing as everybody else, an 80% chance of thunderstorms for tonight. Some of those could be strong or severe. It's something we've got to keep an eye on. Large hail is the primary concern, though, coming up for tonight. And then, let's see. I want to say hello to, we got Colton, Cassidy. Who else we got? Brooklyn, Gino, Drayden, hopefully I said all those names right. Isabel and Travion also watching as well. Almost 11:40 here. I'm going to wrap things up for today so I can get ready for the noon show, and we're waiting for that update coming up at 12:30 also. Tomorrow is going to be fun because we're going to talk about weather balloons, and we're going to talk about observations. But more importantly, tomorrow, I'm going to give you a little homework, but it's going to be fun homework, okay? We're going to just track the weather from starting tomorrow. We'll track the weather all the way into next week, and then that gets us into our forecasting week. So we'll talk a lot more about that coming up in the days ahead. All right, thanks for watching. Days ahead. All right.